Hi class, I hope everyone doing fine. So I just want to go over what ER diagram is and how to model them, okay? I have a tool that I've been using called Jar.io. It is completely online. You guys can use it to create your diagram if you want to. And if you decide to use any other tool, that's fine with me. But if you want to use this tool, then you can also use this video as a tutorial on how you can use the tool to create your model. So first click create diagram, then go into software, then go down to using this template called entity relationship. Just click on it for it to create. The good thing about this tool is that you can save the diagram onto your Google Drive so that you can work on them at a later time, or you can directly persist it to your computer. Whatever way is fine. So what exactly is a ER diagram? Oh yeah, sorry. Because you use a template, it's going to populate all these pre-populated table for you. Just go ahead and delete them all. Okay, then click on the search save type table, then just choose this one. Look good, just choose this guy. Okay, so ER diagram, whenever we try to describe a database, more often than not, people usually would use ER diagram to describe them. When you go for an interview, for like very technical interview, they may just hand you an ER diagram and ask you to describe or walk them through how or what is this diagram telling you. ER diagram, the E stands for entity, the R stands for relationship. So ER diagram also stands for entity relationship diagram. In an ER diagram, you're basically trying to abstract a relationship in real life into database modeling. What an entity is basically an object in real life. A person is an object in real life. School is an object in real life. Institution, a car, the car tire, the laptop, the computer, all of that are entities. Whenever you hear the word entity, you must remember that they always refer to nouns. Okay, noun, not verb, noun. So how would you draw an entity? In an entity, you always start out with a rectangle, right? Then you would give it the name. Give your entity a name. Let's say I'm trying to model the student object in real life, right? So then my entity would be student. That's the name. For an entity, you always have attribute that help to describe what that entity is. For the attribute for a student, you can have name, age, language, the class that the student take, the house address, the student ID, student age, tuition, right? So all of these are the attributes that further describe this student entity. Excuse me. Alright, now in an ER diagram, you're going to have multiple entities, and that diagram will just basically tell you how each of those entities relate to one another. All together, the entity and all the relationship help to describe how everything related. So for a student, if I'm just gonna draw another entity, I can probably have professor. Professor attribute can also be ID, can also be name, can be age, can be whatever, right? Let me zoom in. Okay, now I have two entities, student and professor. Again, an entity always draw using rectangle box, right? Entity can have attributes. Attributes are just information that further describe what what that entity is. One thing you should notice is that my entity and the attribute are all nouns. Right? They're not verb, they are nouns. Now relationship just means how is the student and the professor relate to one another. Whenever you hear relationship in an entity diagram, there can only be three types. One is one-to-one relationship, meaning for object A, there can only be one object B and vice versa. One object B can only be related to one object A. For one-to-many, meaning one object A can be related to object B, object C, object D. A many-to-many relationship just means many object A can be related to many of object B. I'm gonna show you guys all three different relationships, right? But first, whenever you have their entity already and you have already identified their relationship, which means in this case, student can have one or more professor, right? And a professor can also have one or more student. That means the relationship is a many-to-many relationship. So you would just throw all the way down to entity relation. And conveniently, this tool also have all the possible relationship that you can use to describe the relationship between these two entities, student and professor. And we have already identified it is a many-to-many. So then we'll just go to many-to-many and choose it, connect the line to both the entity. The way you would read this is that a student can have many professor can have many student. Okay, so notice how I go from the entity here all the way to this relationship over here, and vice versa. Professor entity map to this relationship. Student can have many professor. A professor can have many student. So that's a many-to-many relationship. Again, entity is always noun. Attributes are also noun. Entity student can have many professor. One professor can have many student. And because I'm lazy, I'm just gonna copy and paste and change the name. Now I may have another entity, say country, right? And I have to change these. Instead of student ID, now be country name, country latitude, and longitude, right? Then I may have capital city. Capital city may have name, population of that city, right? And maybe the year of establishment. So sorry, I'm still haven't got over my code yet. Established year. All right. In this case, a country can only have one and only one capital city. A capital city can only belong to one and only one country. Alright, there's no other relationship for this association. This is pretty similar to real life, right? That's what I mean by ER diagram. It's really just the model that describes something in real life. It's an abstraction of the real life relationship. For a one-to-one, just simply go and look for one-to-one and connect the dots. Right? Even if you draw them by hand, the cardinality, which is this little symbol that basically describes how are they related, those are called cardinality. Cardinality or relationship can have one-to-one, one-to-many, or many-to-many. For this relationship between country and capital city, you would read them as a country can only have one and only one capital city. Capital city must belong to one and only one country. Okay, so for another relationship, we may have car and tire. Right, this relationship it's going to be a one too many. Why? Because a car can have more than one tire, but a tire, right, must belong to one and only one car, right? So that's why tire must belong to one car. Car can have many tires. It's a one to many relationship. So again, just look for one to many and connect their cardinality together. Right, again, read from left to right. Car can have more than one tire. Tire must belong to exactly one car. Okay. Now for a lot of these, you're gonna see you're also gonna see the 0 or 1. This mean entity A can only have 0 or 1 of entity B. You also have more than 0. That means it's optional, right? Entity A doesn't require to have any of entity B, but it can have many of entity B. However, it is not required. Okay, so now again, entities are all nouns. Even for the attribute, you should try and keep them as nouns. The relationship is basically just the cardinality, basically describing how are they related to each other. Student can have many professors. One professor can have many students. So this is a many to many. Then you have one to one, which you would read them as one and only one. One and only one. Then you can also have one to many. Those are the three cardinalities that you're gonna have in an ER diagram. Okay, and also you have something called strong entity versus weak entity. What that means is that a weak entity cannot exist without the strong entity. Its existence is dependable. Is rely on having entity A must first exist. In this example, car and tire. Tire cannot exist without a car. Well, sorry, that's not a good example. Let's use this. Yeah, this is better. For country and capital city, a capital city is a weak entity because capital city cannot exist without a country first exist. But country, on the other hand, is a strong entity because a country can exist without a capital city, right? Nothing requires a country to have a capital city, but a capital city obviously must belong to one country. Okay? So those are ER diagrams. Again, ER diagrams consist of entities and their relationship, which mostly described by their cardinalities between the two entities. Right? In an ER diagram, you're gonna have a lot of entities, and the relationship would just be how entity A relates to entity B relates to entity C, and so on. But again, to reiterate, entity, when you draw them, always use rectangle. Entity must have a name. The name is always noun, right? Entity can also have attributes. Attributes should also be nouns, right? In some cases, you may have entity that may be a verb, but try to also use a noun to describe it. For example, if you're trying to ask a person if he has ate dinner, right? Then your attribute for that person would be ate dinner, true or false, right? But it's still somewhat it's sort of a question, but it's still describe whether or not that person has ate dinner or not, right? Again, entity, relational, this is how they're related. Strong entity just means they can exist by itself. Weak entity meaning it cannot exist without a strong entity first exist. Right, and now if for chapter 3 go further and just basically elaborate more on these entity diagram. If you note, it's basically have supertype and subtype, right? If you notice student and professor, you can pretty much have a supertype for these, right? And the supertype could probably be just a person, right? A person. A student is a person. A professor is also a person, right? So now person is basically the supertype of student and professor. Okay, usually you wouldn't describe it like this in a database. You would have you never have a table called person. You would have instead two tables called student and professor, right? But I just want to show you what chapter 3 mean. Student and professor can be generalized, right? Generalization can be generalized into person. Person can be student or professor, right? So student and professor are the subtype of person. If you have a supertype, that means all these attributes of the supertype can be or must be shared among all of its children type or subtypes. So in this case, both student and professor can have name, right? Name can be an attribute of student. Name can also be an attribute of professor. They can also have ID. They can also have age, right? So these attributes describe a person. A person can be a student or can be a professor. Student and professor are subtype of person. Person is the supertype of student and professor. Right? Now, because these attributes already exist in the person, you wouldn't have to redefine this attribute again when you go to the student and the professor, because student and professor, since they are subtype or children of person, they will also inherit the attributes of the person. That's what it means by supertype. That's what it means by supertype, subtype, right? Or another word for this would be generalization. You generalize student and professor to be a person. Right. So now what are some specific attributes that a student may have? Student may have debt, right? But debt can also belong to the person. So student can have classes, right? Student can also have books, right? Student can have cars. Professor can have the also book but manual book, for example. Professor can also have grade. They can rate the student. Well, professor also have let's see what a professor has that a student doesn't. It's pretty much nothing besides just the manual book and the part which you read, right? But so yeah, sorry, this is a bad example, but you get the idea. A person again is supertype of student and professor. Student and professor are subtype of person. That's what generalization is, and that's what pretty much what chapter 3 trying to tell you is how you can further generalize the relationship between two entities and make them into just one generalized entity. Okay. In real life practice though, you're gonna have these two tables, student and professor. You're not gonna have a table called person, because a table cannot really inherit from one another. The inheritance is defined in the code, in the ASP programming language, which is not a concentration of this class. So just focus on this, but also know that these can be generalized into a different entity. Okay, so to reiterate, you have entity, you have relationship, you have cardinalities, right? Entity names are always noun. Cardinality is one to one, one to many, many to many. Strong entity can exist by itself. Weak entity cannot exist without a strong entity. Okay, feel free to message me if you have any question. For your assignment, you only have to do part A of the assignment. Okay, don't do part B. And part A is due on Labor Day by midnight. So please don't forget that. If you have question and need to reach out to me, students have told me that when they try to email me, the email bounce back. So please don't email me from D2L. Right? If you're gonna do that, just send me a message in D2L instead. If you wanna email me, use your student email or your personal email. Just send me an email. I generally respond within 24 hours. All right. Thank you for your time. Bye bye.